Hello everyone again. We're going to go into 4.7, the transformations of polynomial functions. So this lesson is actually kind of a review lesson because transformations is not something new we've done. We've done it a couple times already, so it's going to be a bit of a review. We're just going to now apply it to the polynomial functions. So we're going to be describing transformations and writing transformations of these polynomial functions. But first, let's go ahead and do a joke of the day. So what does a frog say when it sees something great? Here we go. Totally awesome. Totally awesome. Because a frog is a toad. Alright, so jumping into 4.7, right there on page 106. Take a look at page 106. You got some graphs right there at the beginning. We're going to just look at these. So we have polynomial functions like x to the third, and you're going to see x to the fourth next. If it's an odd exponent like x to the third or x to the fifth, remember it's like this, where it's one is going up and one is going down. It's doing that kind of snake thing across the graph. This is the parent function for the x to the third function, where it goes right through 0, 0 right there at the middle, and it's going up this way and down this way. So here's four other graphs that are also x to the third functions, but there's a little bit of a transformation going on. Letter A, you can go and write this down. It's the g of x is equal to what this is here. You can see what's moved to the right a bit, and so that means it's going to be an h number if it's moving left or right. It's x minus 2 inside here, and then to the third power. On B, this one is changed kind of direction. So instead of going from down to up here in the first quadrant, it's now going from top to bottom over here in the fourth quadrant. So what that happened is a reflection that just basically reflected over the x-axis. So it's just going to be a negative in front of that one. And this one you can see moved up on this one. So it was from it starts at 0, 0 here. It moved up 2 units. So you're just adding 2 on that one. So x to the third plus 2 for this one. This one did two things. It moved to the left and it moved down. So it moved to the left 2 units. That's why we're going to put x plus 2. Remember, it's always the opposite of what that seems. Negative 2 would be plus 2 when we go in here. And it moved down. It is the same. So down is a negative 1. You add that to the end of this. X plus 2 to the third power minus 1. If you need to see this still some more, you can pause the video. But let's move on to the next page, 107, and we're going to look at the x to the fourth function here. And this would be true for any even exponent. So even an x squared function, a quadratic, kind of looks the same and has the same characteristics as this one does. Or an x to the sixth would have the same characteristics as well. We'll see a couple of those in the lesson here. But this again is the parent function for x to the fourth, right over here next to it. Starting again at 0, 0, it's going up. Then remember, when it's an even exponent, both are headed up here. Both are going in the same direction, especially if it's positive. So this is going to be the parent function for just x to the fourth. And then letter A, you can see it moved, looks like it moved right 2 units and down 2 units. So that's what we have now. We're going to have an h and a k number kind of on this one. We're going to put x minus 2 from moving right 2 units. That always is opposite. And then it goes down 2 units. That's negative 2 in the back for that one. And this has the fourth power there. This one looks like it flipped and it also moved. So it moved from 0, 0, went right 2 and up 2, but it also flipped upside down, which means we're going to put a negative in front of this parenthesis. So if it moves right 2, it's also going to have the x minus 2, just like this one did. And moving up 2, which means we're going to put plus 2 on this one instead of minus 2 like it was on this one when it went down 2. But we put the negative in front because it's opening down. So hopefully this was a bit of reminder about some of those things with the transformations. On page 108, if you look at page 108 next, here's our core concept, and it has all the transformations. We've seen something very similar to this. Now it's just applied to, this one's applied to x to the fourth functions, so polynomial functions here, but you have your different transformations here. We have our translations, which is your h and k numbers. You have your reflection, which is the negative sign, and it is either in x-axis or y-axis. If it's in the x-axis, it's going to be applied to the entire function times the entire thing. If it's the y-axis, it's just going to be x only. And then our horizontal and vertical stretching and shrinking, which is your a number. The reflection could be an a number as well, just means a is a negative on this one. But here's a number other than 1 if for horizontal stretching or vertical stretching or shrinking. And I wrote just up here again, when it's horizontal, you're doing whatever you're doing to the inside of the function. So you can see here, horizontal translation, we're inside where x is. The reflection, the one that's inside is over the y-axis. That's a horizontal reflection. And then the horizontal stretching and shrinking, you're multiplying a times the x on the inside. So you can see those are on the inside here of the parenthesis, on all of those, inside the parenthesis. When it's vertical, you're outside. So it's on the outside of this parenthesis. So you can see vertical for the k is outside. When it's a reflection over the x-axis, that's a vertical reflection, it's outside and front. And when it's a vertical stretching or shrinking, the a is multiplying the outside of this whole function. So it's outside a parenthesis. So we just got to keep that in mind as we're working through this. Okay, so let's take a look now at the extra practice for our assignment here. So page 109, just moving along, go on to page 109. And number 1 and 2, it says describe the transformation of f. So here's our f. F is the parent function represented by g. So g is a new function, and we're going to describe the transformation. Then it says to graph each function. So here's our core concept. Again, we want to look at this core concept to be able to constantly, every time, you want to look at this core concept to help you. So this one has x to the 4th minus 9. That's a k number, so we're looking at the k number here. So we're going to call this a vertical translation. And since this is a negative, it's going to be going down this many units, 9 units. And so you can see here's what we have for that one. So vertical translation, 9 units down. And here's the graph of it. You can go ahead and graph this as well. Just putting your x-axis and y-axis down through the middle. Your parent function's in black, and our new function here just went down 9 units. And every box here I'm doing as is 2 units. So there's -2, -4, -6, -8, so -9 would be here. And then it's just going up again from that point. Having the same, it should have the same shape, just it's moved down. Number 2, you can see on this one, this has got an x to the 5th function. So it's not going to be, arrows are not going to be both the same. It's going to be 1 up and 1 down because it's an odd degree here. You have h and k on this one. So you can see inside the parenthesis, there's an h number and you have a k number. So there's 2 things now to say for the describing transformation. So we're going to do the horizontal translation. So you can see where there's going to be a horizontal translation for h, always the opposite. So it's going to be, on this one you can see it's moving left. So if it's positive 1, it's going to move left this many units. And this one's going to go up 2 units here. So it should look like this now. So horizontal translation, 1 unit left, and then also 2 units up. Vertical translation, 2 units up. And here's the graph. You can also graph this as well, just down the middle again and through the middle. So our parent function is here in black. That's going through 0, 0, and then just going to go up. It's going to go up to 1, 1, and then -1, -1. So every box is worth 1 here, and it does that kind of up and down thing. And this one's going to move. It's going to move left 1 unit and up 2 units. So there's the center of it, and then it has the same kind of shape. And it's going to go up 1, right 1, down 1, left 1, and then you just do your curve, the snake graph going through that. The x to the 3rd looks very similar to this. This one's a little more narrow than that one. The x to the 3rd would probably go out a little further with these arrows coming down. It would have the same kind of characteristic right here in the middle, but as the arrows go out, it'll go out a little further this way. The x to the 5th is a little more thin and narrow. X to the 7th would even be still a little more narrow than that. All right, let's take a look at the next couple problems. Number 3, this is an x to the 6th problem. So again, we're going to be up on both of these. So it's kind of similar to the x to the 4th. It has a number in front of this parenthesis and a number inside the parentheses. So the inside one is an H and the one in front is an A, and it's also negative. So there's really three things we're going to say for this one. We're going to talk about the negative, which is going to be a reflection. The A is going to be a vertical stretch because it's on the outside, and then we're going to have the H number with the horizontal translation. So it's going to be a reflection in the x-axis for the negative, just like this one is, because it's outside. It's x-axis. If the negative was on the inside with x, that would be in the y-axis. So we're outside. And then it's going to have an A number on the outside, so it's vertical. And since that's a 5, it's going to be exactly what it is. So it's a, like this 8 here, it's a stretch by 5 on ours. So it's going to stretch by 5, and then it's also going to have this H number. It's going to have a horizontal translation, and it's going to be going right 2 units. So that's what we should be saying for this one. Reflection in x-axis, vertical stretch by factor of 5, horizontal translation 2 units right. So I know that you have this core concept in your notes right there on page 108, so you can keep looking at that, but I'm going to keep showing you this the entire time. And you can also look at the graphs here. Again, they're both going up for your x to the 6th. Well, this one's going to have a reflection, so they're both going down. It's going to be a little narrower than this one here, so you see it's a little narrower as it comes down, and it also shifted right 2 units. So it went 2 units to the right, down this way. So here's our new one in blue. Number 4, we got x to the 3rd, so 1 arrow up, 1 arrow down on this one. We have a 1/2 in front of x inside this parentheses, so there's your A number. That's going to be a horizontal one because A is inside, right there, just like that. And then we also have a K number because that's on the outside. So we're going to have a horizontal, and whenever it's like right here, here's one exactly like that with 1/2 x, just like it. So you can see it's going to stretch by 2. Remember, what's inside is always like the reciprocal of what that number is. So when it was 1/2 here, it's going to stretch by 2, but when it's 2, if it's a whole number, it's going to take the reciprocal of that for your factor number and say shrink by 1/2. So the stretching and shrinking is always depending on the factor number there. So if it's less than 1, it's going to shrink here for this number. If this number is more than 1, it's going to stretch. But when it's inside here, it's always the opposite of what that factor number is. The vertical one is always the same, as you can see. Vertical is the same. And we also have a vertical translation. This one's going to go 4 units down, just like it says here on this one too. So again, just keep looking back at this, and you can use this to keep helping yourself. So this is what we're seeing here. Horizontal stretch by factor of 2. Vertical translation 4 units down. That's the description of the transformation. And here's the 2 graphs. There's our x to the 3rd function. So it looks like the x to the 5th, but it goes out a little further here. It's not as narrow. And then this one's it's going to come down 4 units. So 1, 2, 3, 4 units there for that point. And it's also going to be a little bit wider in this case. So this one goes up 1 and right 1. But since this is a 1/2, you're going to go up 1 and right 2. So it's kind of like, that slope for that to get that point there. But it's going to be a curve like a snake going up. And down 1, left 2 for the other one coming down this way. Okay, I know I'm going kind of fast, but you can always pause the video if I'm going too fast and you need to catch up. And you can always rewind and see it. 5 and 6. So take a look at 5 and 6. You can pause the video right now and try 5 and 6 on your own. See if you can do these correctly. It's got an x to the 4th here on this one, and this one has an x to the 5th. So pause my video here and try to see if you can do these, and then see if you're correct. But I'll keep going, and then you can see what you got. Okay, hopefully you did try these already, and you paused the video. But this one, you can see there's a number in front here. That's going to be an A number outside. That's vertical, and since it's less than 1, it's going to be shrinking by that number. So it's going to be a shrink by a 1/8. And a negative sign is inside with x. That's just like this one here, reflection. So it's going to be reflection over the y-axis in this one. So that's what you would be saying for this one. Vertical shrink by the factor of 1/8 and the reflection on the y-axis. And here's our graph for this one. Their parent graph is right there. You've already seen that before. This was now just a little bit wider, so it's going out a little bit wider here for that, with the 1/8 being there. And since it's a negative inside here, you think a reflection over the y-axis. Well, it doesn't really change anything about that when you have this. And reflecting over the y-axis is just going to kind of reflect it on top of itself. So it really only looks different if the negative's in front outside here, because then it will open down. Number 6, yeah, hopefully you did this one already as well. But we have a H number here and a K number. That's all we have in this one. There's no A number, there's no reflection. So it's just the top two here we're going to be talking about. So this is going to be, since it says -10, it's really +10. So it's going to go right 10 units. And this is going to go up 1 unit. So that's just our H and our K's here doing that. So that's what you're seeing here. Horizontal translation, 10 units right. Vertical translation, 1 unit up. And here's our parent graph with this x to the 5th function, and then I just moved it 10 units over here to the right, 1 unit up. It looks like every box is 2 for me here if I put this right through the middle with our coordinate plane. So every box is 2, so that's why I went 1 and 1 for there, -1, -1 for there, and then 10 is all the way over here to the side, and up half is 1. And then I just mirrored that same function just over here. It stays the same shape. Okay, number 7, now we kind of changed gears a little bit with number 7. It's a little bit different. It says graph the function g of x is equal to -f, and then in the parenthesis x minus 3 on the same coordinate plane as the f of x. So here's the f of x. We just want to graph g of x function on this same coordinate plane. Okay, so we're going to keep this in mind, the core concept. First of all, you can see it says -f. So if you go up over here, here's a -f right here where it's a reflection over the x-axis. So we're going to be reflecting this down. It's going to be opening down. And it has an x minus 3, so that's an h number there. So it looks like this one right here. It's going to be a horizontal translation. And so it's going to be going 3 units to the right. So if we start with 3 units to the right, so this is at 3 right now, so 3 more units takes me to 6, and then I'm going to open this down, so it's just going to come down. It's going to stay the same shape as that. You can see we're going 1 to the right, 1 up, 1 to the left, 1 up to get that, so I can do that here. So here's 1 point there, and then another point's going to be 1 right, 1 down, 1 left, 1 down, and I'm just going to kind of try to make this as best I can, looking like that. So kind of coming down there and coming down this side over here. So just try to do the best you can at sketching that. That's all that was. Just kind of trying to realize that you're going to use the notations here to help you graph this function, this new function using this notation. It means a reflection in the x-axis and a horizontal translation of 3 units to the right. And we just did that. Alright, so that's on page 110. So now we're on page 110. Number 8 and 9 on 110 are right here. So I've already shown you the graphs, and this looks kind of wild here with these, graphs going across here. But we don't have any parent graphs here. It says write a rule. So we're going to write a rule this time for g and then graph each function. So here's the graphs of the function, but we could maybe do that after we've written the rule. So here's our rule for this, and we want to realize what's going on. So if this is the f and this is what's going to happen to f. So you can see again, use our core concept down here. I'll bring this up here again just so we can kind of see how this works. So it's got a -x here, which means x is inside. That's going to be, reflecting over the y-axis. And so you can see we're just going to put that inside there where x is. And so that's what I did. So here's where the x is. Now it's going to be -x to the 3rd power there. And then the -9, that's going to be added to the end of our function. So that's added to the back of our function. Okay, so now that we have this down, we just want to clean this up. We would say, okay, -x to the 3rd power. 3 negatives is still going to be negative, so we'll have -x to the 3rd. and then these two combine to give us a -1. So there's the rule for g of x. And then we could graph this. So here's the graphs. Here's f of x's graph right here. So there's your middle point. Let's just put a point right there. So you got a point right here. There's a middle point. Then you're going to just kind of go up from there. Looks like every box is 2, as you can see, and then the other one's just going to come down this way. It looks like it's going through right here as well. There's a point right there. You can put it through that. And then here's the other one. Middle point looks like it's right here at -1, as you can see right there, -1. And then it's going to be going up, and looks like we're going through maybe this point right up in here. There's another point you can maybe try to shoot for. And then this one comes down, and maybe this one's going to kind of go towards this point over here. So you can do your best at trying to graph those kind of squiggly lines there on the graph. It also said to describe the graph of g as a transformation of this graph. So what would this transformation be? Well, we can see right there the negative sign inside there. Well, that's a reflection over the y-axis. So we could also write that down. So let's write down that it's got a reflection in y-axis. And the second thing is that it's got this -9, so it's got a vertical translation. And it's going to be going 9 units down. So 9 units down. Okay, so problem number 9, same thing. So we have here's a polynomial function, kind of a bigger one here. It's 3 terms in it. Still, it's x to the 5th, so it should be doing that 1 up, 1 down situation. And this only shows us one thing we're doing to it. This had 2 things we were doing. This is just multiplying the function by 5. So if you look at your your core concept here, down here at the bottom, where a is multiplying the function, and we're multiplying by 5, just like 8 was multiplying this x to the 4th, it's going to be stretching by that number 5 here. So we just got to multiply this entire function by 5. So it's like a distributive property. So let's go ahead and show that here down below. You can see here's the graphs looks really kind of strange on this one, but here's what you really want to get here more than the graphs is getting this answer. So the g of x is 5 times that function, so just distribute the 5 into there, and now you have the g of x function. And so you could try to do the graphs the best you can. I know it's really kind of a squiggly mess kind of in the middle here, but you got a point going right through there. You can see that point is here. Then you're going up a little bit, then down quickly, and you're kind of shooting maybe for this point down in here. And then this one goes kind of a little roller coaster down and then goes up. On this other graph for the f of x, now that was actually g of x, the one we just had here. The f of x one is down here. There's your y-intercept here is at 1, which you can see there, it's 1 there. This one is 5, and so you can see there's 5 right here. So this one's a little bit not as pronounced inside here, so just a little raise and then go down towards that point. This one just kind of goes down a little bit and then starts going up. So just do your best at trying to draw those. And then if we want to describe the transformation from this one to this one, we're just describing this 5 here, and like I said, that's going to be, if we look at this core concept again, just down at the bottom when we're looking at that, right here, it's going to be a vertical stretch by 5. That's all we have to say. Vertical stretch by 5. So we'll write that down. So vertical stretch by factor of 5. We can say factor of 5 because 5 is the factor right there. Okay, moving on to the last 2 problems. That would be 10 and 11. So 10 and 11 are here. So we're going to write a rule again on this one. We're writing a rule just like we were doing on the last one for g that represents the indicated transformation of the graph of f. So here's our our f of x function, and it tells us the description. We're just going to take that description and write a function from this. So we got to perform these kind of operations here, these transformation operations to this function to do this. And we just kind of do one at a time, just start to go across here one at a time. We have really 3 of them. So you got your translation, and then it's got a reflection, and then it's got a vertical stretch. So there's 3 different things that we have to do here. So starting with the translation of 1 unit to the left. So if we look at what that does to the graph, again, here's our core concept. So 1 unit to the left. So here's units to the left. It's like this. You're going to be putting x plus 1, our number is 1, inside where you see x. Well, there's 2 places we see x there. So it's got to go into 2 places for this. So we're going to start with doing it this way. So this is going to be our g of x function. We'll start to build our g of x function from this. And instead of x, we're going to now put x. And then we're going to put left 1 unit, so it's plus 1. X plus 1 cubed. Then minus 6. And then x plus 1 squared. Then plus 5. Okay, so that's the first part. The next one, so we're using the same function, is that it's followed by a reflection. So we'll do this one in a different color. So this we'll do in green here. So the reflection in the x-axis, which means that's going to be a negative sign. So let's look at where that would be on the core concept. So reflection here in x-axis is where we multiply the outside of the whole function by a negative. And so we're going to multiply the outside of this whole thing by a negative, which is going to change the sign of all of these. So now we're going to just have a negative in front of this one, and it'll be x plus 1 to the 3rd power. This will change signs to positive 6, and then x plus 1 squared, and this will become negative 5. It just changes everything on the outside of the parentheses, their signs, when we're going to multiply everything here by a negative. So maybe I should just put outside here what we're doing. So this one we were saying f of x plus 1, and then this one we were saying f actually like that, negative times f of x. And so that's what we did there. And this last one, which is going to be the stretch, the vertical stretch, I'll do this one in blue, the stretch by the factor of 2 here. That's this one. Don't mean to line that out, but you can see what it is. I'm kind of trying to highlight the 3rd one here. Stretch by a factor of 2. That means we're going to be multiplying the outside, as you can see on the core concept, right down here at the bottom. It's a vertical stretch right here by a factor of 2. So you're multiplying the outside of the whole function here by a 2. If it was horizontal, it would be the opposite of what that number would be. So we can say now for this one it's going to be 2 times the f of x. Actually, I'll just put it like this. I don't need the parenthesis there. So it'll say 2 and then f of x like this. I'm going to multiply 2 times this whole f of x, which is what we have here in green now. So now if I multiply the outside by 2, negative times 2 would be negative 2 in front of this one. X plus 1 to the 3rd power. 6 times 2 on this one is 12, so 12, and then x plus 1 to the 2nd power. And then negative 5 times 2 is negative 10. So there's our final g of x answer. So that's what we're trying to get to for the final answer here. That's the final rule after we did the last one. Okay, so now that you saw me do that one, try to pause the video now and try to do number 11. See if you can do the same thing for number 11. There's going to be 1 horizontal shrink, and then there's a translation 8 units down, and then the last one's reflection on the y-axis. So use that core concept there on page 108. Try to do that. See if you can get the right function there at the end, and then push play again and see if you got the answer correct. Okay, so hopefully you paused it and now you're just checking your answer. So the first one says horizontal shrink by the factor of the 1/3. So if we look at our core concept, what that's going to do to this horizontal shrink, which means we're going to be multiplying the inside here, and it's by a factor of 1/3. So if it's going to shrink by a factor of 1/3, like this one says shrink by a factor of 1/2, notice what we're multiplying the inside with is 2. So it's really the reciprocal of 1/3, so we're going to be multiplying by 3 on this one. So we'll start by saying over here f of 3x. So we're going to multiply 3 times the x in each one of these. So what we're going to see here for our g of x function for the first part is 3 times 3x to the 4th power plus, this is just going to be inside the parentheses 3x to the 3rd power, and then this will be 3 times 3x to the 2nd power, then plus 12. So where every x was, I put it in parentheses as a 3x. But now we still got to kind of clean that up a little bit. We should clean this up because we could say 3x to the 4th power is something else and clean up each of these terms. So obviously we're still going to have x to the 4th, but 3 to the 4th power, we can try to see what that is using a calculator. So we could say 3 times 3, that's 9, times 3 is 27, times 3 is 81. So it's 81 for here, but then I got to multiply it by another 3, so 81 times 3 is really 243. So this is really going to now become 243 x to the 4th right there. Okay, then we're going to see plus, and it's going to end up becoming, let's see, this one is going to be 3 to the 3rd power, which is 27, like we saw a second ago, 27x to the 3rd power. And this one's going to be 9 with 3 squared, but then times 3 is also 27, so 27x squared on that one, then plus the 12. So that's just the first one there. Let's go with the second one now. It says translation 8 units down. So what that means we're going to do is a k number, so we're going to see f of x, and we're going to subtract it by 8. So we just got to put a minus 8 here at the end of this. So it's still going to be 243x to the 4th, or 27x to the 3rd. All these just get copied down. But now, right here, we're going to just basically do this. Subtract 8 from the back of this function. So 12 minus 8 would give us 4. So plus 4 at the end of this function. That's the next one. The last one is a reflection in the y-axis. So reflection in the y-axis here for our last one. So what's that going to do? That's going to be in the y-axis. Remember, if we look back at our core concept, keep referring to it. So there's a reflection one right here. Reflection, when it's in y-axis, the negative is going to be on the inside with x. So that's what we got to do. That's the notation we can put down. So it's going to be on the inside with x. So it's going to be like this, f of negative x inside there. So our final thing here was going to say, so 243 negative, this is a negative x to the 4th power. So we can, just do 243, I'll just write it in here, negative x to the 4th power there. This is 27, a negative x to the 3rd power here, plus 27, and a negative x to the 2nd power here, and then our plus 4. 4 does not get affected because in the y-axis it's only the x's on the inside getting affected, not the outside of every term. So now sometimes this does affect the outside if you are going to end up with either an even number of negatives or an odd number of negatives. This is to the 3rd power. So an even number of negatives is actually a positive. So negative x to the 4th power is just going to be an x here. So this one's going to stay. So let's put g of x down here. This one's going to stay positive 243 x to the 4th. but an odd number of negatives is really going to make this 27 negative. It's going to change its sign to negative 27 x to the third. 3 negatives is still going to be negative to multiply 27 with. Here's an even number, so it's going to be a positive. It's going to stay positive. So this will be positive times positive, so it stays positive 27x squared, and we have our positive 4 at the end. And there's our final answer for writing this rule with that description, those 3 descriptions for the transformation. Okay, so that concludes the lesson, and hopefully you should be ready now to go on to the assignment and be able to do these on the Big Ideas assignment page there on the computer. All right, I'll see you in class.